Welcome to our next videos, and tonight we're going to be talking about tough trinomials. And so you might be saying, why are they tough? Well, it's because of this bad boy right there, that's 6. So far up to now we've only dealt with trinomials that have had a 1 for a coefficient there. So the standard form of a quadratic is ax squared plus bx plus c. A, b, and c are just numbers, and so far we've only had a equals 1 for our trinomials. In other words, they just start off x squared or 1x squared, but we don't think about the 1 at all. They start off 1x squared, and then we can factor them. We don't usually have to think about it. We start and we put an x here and an x here, and we just figure out the factors of this one, and throw them in, and call it a day. So we can't do that for this one. There's going to be factors of that 6 involved. And there is a couple cool tricks. I'm going to show you one of the tricks today that I think is the best trick. But I'm going to first show you that what you'd have to go through without a trick. And it's kind of awful. So take a look at this. 6x squared plus x minus 2. So if we didn't have a trick, we just start by doing this standard thing. The x still goes here, but I'm leaving space right here for a number to go there. Why is that? Okay, there we go. X. So there's going to be a number in front of each one. I'm not sure what numbers yet. And there's going to be the standard, numbers afterwards too. So I'm still over here thinking about factors of -2. So that would only be 1 and 2. Like that's the only possible factor set. So this would be an easier tough one because of the low amount of factor combinations there could be. So 1 and 2 over there. For the 6, so there's a couple. There's 6 and 1. There's also 3 and 2. So the thing is, it can be a combination of any one of these and this one. So in my mind, I start throwing numbers in. I'm going to use a different color for my thinking out loud. Let's use maybe something yellow. Yellow seems like thinking. So maybe I'll throw a 6 in here and the 1 in here. So if I use the 6, I have to also use the 1 because 6 times 1 is 6. And then I come over here and now it's a -2. So one of these has to be negative. So now I have even more choices. Is it the 1 that's negative and the 2 is positive, or is it the 1 that's positive and the 2 is negative? It's just awful. So I'm just going to take a guess. Let's say 1 and 2 goes like this. -1, +2. So at this point, I would check to see how right I am. And to do that, I multiply the outside numbers, the 6 and the 2, and I get 12x. And then I multiply my inside numbers, and I get -1 and 1. And that gives me a -1x. Well, when I combine those, I get 11x. This is what I wanted. I wanted 1x. So 11x is not going to work. So I go back to the drawing board and say, okay, it wasn't 6 and 1 with -1 and 2 there, but maybe the signs change. Maybe it's 3 and 2 and not 6 and 1. And like I said, a big yucky mess. So I'm going to show you the cool trick that makes it just a kind of standard procedure each time. Okay, so how many of you wrote all that and then I told you that it was a piece of junk, right? Sorry about that. So wouldn't it be nice if we just get rid of the 6? So I think someone thought that and said, hey, let's just get rid of the 6. Then it would be easy. And that's essentially what you do at first. So we're going to rewrite this with x squared plus x. And then instead of writing -2, we're going to take these two numbers. So the 6, let me get rid of that. So the 6 and the -2, and we're going to multiply them. So that would be 6 times -2 equals -12, and that's what goes at the end of here. Okay, so this is just from the original without the 6, and then this comes from multiplying the outside numbers. Alright, now we factor this like you normally would. So this is from last class. You're going to factor this using factors of 12. negative 12. So I know because it's negative 12, I know it's one of each sign. And it's either going to be 12 and 1, or 6 and 2, 3 and 4. But it's easy to come up with the right one because I don't have to worry about any number over here at all. So I want a 1. I want a 1x. So I need something that's a difference of 1. And that would be the 3 and the 4. So I'm going to put a 3 here, a 4 here, and I look at my sign again. I want, excuse me, not that sign. Whoops. I look at my sign in the middle, and it's a positive. So I want my bigger number to be positive, so that when they combine and I get a 4x and a negative 3x, that makes positive 1x instead of negative 1x. So I have x plus 4 and x minus 3. Obviously that's not the answer to my original problem because that's the answer to this one. So here's what we do. You take your x plus 4 and you divide by that 6 that we took out. And you write the other one, x minus 3 divided by that 6 that we took out. So far you're probably saying, this doesn't look easier, this looks like stupid fractions. I promise it's going to get cool in just a second. Change back to white. So now you just reduce x plus, this is really important that you do have to reduce every time. So 4 over 6 is 2 over 3. X minus, so this would just be 1/2. Now you take the denominators and you just stick them up in front of the x. So now I have 3x plus 2 and 2x minus 1. Now if you remember from earlier when we were trying to figure out which way it could be, this was one of the combinations, but it was one of quite a few, and we had very little options to choose from, and it got that complicated. So imagine if you had a ton of options. Imagine if this was a 36 up here, and you had all these factor sets. And then imagine if this was still 6 and you had these 2 factor sets. So many different combinations. This method makes it, there's no guessing. You just go through and do it. So those are my factors. 3x plus 2, 2x minus 1. I'm going to end this video now. It's going to be the longest one. We're going to do a couple more examples in the next videos. I'm going to show you how to check to see if you did it right, and we're going to do a factor completely one.